Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today. It's called minimum equals sum of two arrays after replacing the zeros. So we have two arrays as the question has suggested, and they are so they are both like 100k long at most, and all of the numbers inside are non-negative, but it could get quite large. So it could get to 1,000,000. So let's see what the question wants. So yeah, you're given like two arrays. You have to replace all the zeros in both arrays. So you have to replace all the zeros with strictly positive integers, such that the sum of elements of both arrays becomes equal. So once you return the minimum equal sum you can obtain, or -1 if it is impossible. Right. So I think like if we look at some example, it would be a lot more clearer. So for example, with this one, the non-zero digits adds up to 6. It adds up to 11 here. So that means the minimum we could go for is like, if we have a 1 here, and then we make these like add up to 6. So that'll be one way. And then for this one, because the smallest number, we can turn the zeros into a 1, right? Well, if that's the case, this side would be at least 6. And yeah, and like you can't really do anything with that part. So I guess like we have a bunch of cases. So the first one is like, if one array is fixed, that means like the other array has to try to get to them. And well, obviously you have the case where like both of them are fixed as well. And then, yeah, actually what happens if both of them are fixed? I think you just return the, like if they're equal, you just return the sum. Otherwise you just return -1. So that's the first case. The second case, like as I mentioned before, is like if one side is fixed, then like obviously the other side you have to like modify it. The third case is if both sides have 0. So from my intuition, I feel like if both sides have zeros, it should, like there should be a solution regardless. So because like the zeros are wildcards, right? So for example, if you have like 2020 and then like you have 140, even if you have like a really large number on one side, let's say like, and you only have like 10 here, you can always like tune this 0 to be like really big, so that like you can account for the other side, right? So if that's the case, that means we want to make one side, equal to the minimum of the other side. So like for example, for this side, the minimum is going to be 5. Well, because the smallest number we can turn the zeros into a 1, right? Well, for this side, it would be like it's actually 10,000. I said 1,000,000. So it will be like 1 plus 4 plus 1, which is like 6 here. So that means like that's the smallest we can do, like to turn to that side. So yeah, I think, yeah, let's look at this example. So this side, like the smallest it can go to is 12, and that side also has 0. So yeah, I think that'll work. So let's start coding. So the two things we want is I guess I left number of zeros and right number of zeros. So those are the two things we want, which is going to be let's just do a loop to let's just do this in a more Pythonic way, I guess. So we can do something like length of x for x in nums1. Let's just call it like nums1 0, something like that. Yeah, I'm using bad names here, but whatever. So if x is equal to 0, we can just copy that So here we can just turn that into 2. And then we want to find the sum. So we have like sum1, sum2. Nums1 and then sum nums2. So I think we will have all the information we need now. So if nums1c equals nums2c equals 0, well, we just have to check. Return sum1 if sum1 is equal to sum2, because they're equal. That means like they're already valid already. Otherwise, they're not valid. We want to return 1. The other case is, so if one of them is equal to 0, so we have checked the AND case. So that means like if we use OR here, we will check if either one of them is, and if none of them are, you just want to like do the thing outside. So yeah, I guess here what we can do is like we can just return the maximum of either sum1 plus the number of zeros, or sum2 plus the number of zeros on nums2. So this is the harder case, I guess. Yeah, I haven't thought about it too much yet, but it means like we want one side. Yeah, so we want one side to be equal to the other side. So I guess what we can do is we can just check whether the side with 0 can actually reach the side with no zeros. And if it does, we want to return the other side, right? So I guess like we kind of need two cases here. So if there are no zeros on nums1, that means nums2 have to try to reach nums1's sum. So let's do something like, I think like return sum1. If the sum of nums1 is greater or equal to sum2 plus the number of zeros, because like that's the minimum we can form on sum2. If this thing is bigger, so something like this case, right? Like because that side is 6, well we can't return anything, right? We just do -1 here, and then for here, for here, it'll be nums2 here, and then we'll basically just swap all the stuff around, and this should work, I think. I hope. What? It did it again. It just got rid of my code. Oh, it has happened the second time already. This is kind of annoying. I'm not sure why LeetCode is doing this, but I'll just code it up very quickly. So feel free to skip ahead. Yeah. So nums1. Yeah. So nums1c, nums2c is x for x in nums1. If x is 0, then we want the length of that. So we want the length of that, and then sum1, sum2. Yeah, so if nums1c equals nums2c equals 0, we just want to return sum1. If sum1 is equal to sum2, else -1. So if nums1c is equal to 0, just want to return someone. If someone is larger or equal to nums2c plus sum2 else minus 1. Then we just want to swap all these around, and then oops. And then we can just return the maximum of sum1 plus nums1c, sum2 plus nums2c. Hopefully it doesn't delete my code. Maybe I'll copy it just so that it doesn't act up. Yeah, there we go. Yeah, it's very unfortunate my code got removed, but yeah, let's talk about how I thought about this question. So, I think like it's very clear that there are like different cases. So like for example, like there are some very simple cases, right? Like if both of them don't have 0, then well, if they don't have 0, they can't change their sum, right? So if that's the case, we don't have to do any operations here, because like the only operation we can do is replace the zeros, right? And well, we have to replace all of them. The second case is when both sides do have 0. Well, like I think like as I've mentioned before, so like let's say like nums1, and then you have like some zeros. I don't know, like let's say you have like n zeros, and then you have like nums2 with like m zeros. So like if you have the sum here, so let's call this sum like p, let's call this q. So we want p plus like something is equal to like q plus something, right? But because of this something, like we can put any positive number here. So that means like technically we can just put like q here and then p here, right? So like that means we always have a way to like solve it, I guess. But if like let's say q is bigger, then that means like q, like let's say q is like p plus c or something like that, and like all of them are positive integers, let's say. Then like for the something that we want to add, well, we just want to add c here, right? So like to make both sides equal. So this is kind of what I did for the like if both sides have 0 to get the minimum. And then like the third case is like obviously if one side is fixed, well the other side has to try to match it. So yeah, that's kind of how I thought of solving the question. Yeah, there isn't like any algorithms involved in this question, I guess. But yeah, if you're gotten up to here, thank you for watching. And if you have any comments, please leave it below. And I'll see you tomorrow. Bye.